Okay, in this video you can learn about motion graphs and also acceleration. So objectives then, referring back to an earlier one, just being able to describe the difference between distance and displacement. Describe the difference between speed and velocity, they were in a previous video, but it's related here as well. Be able to draw and interpret distance-time graphs, and be able to calculate speed or velocity from a distance-time graph. And also, at a higher level, to be able to draw tangents to curved lines to work out the speed when an object is accelerating. Quick check of the spec, referring back to velocity, knowing what velocity is. And then the distance-time relationship I'm going to cover in this video. To explain displacement-time graphs, it's best to look at an example. So just drawing you here an example of some person moving so we can have a look at the different sections. The first section there is a straight line, a diagonal line. This represents a steady speed. You can see that he moves 10 meters in 20 seconds, and because it's straight, that means a steady speed. The second section is horizontal. That means he stays at 10 meters, so horizontal means stationary. A steeper line means a faster steady speed, and a diagonal line going downwards would mean a speed in the opposite direction. You can still calculate the speed, but if you were to calculate the velocity, this would be a minus number showing it's going back, and that person would arrive back at zero at this same place he started with, so his overall displacement would be zero. So if you want to sketch this in your book, let's just ask some questions. What is the speed in the first 20 seconds? Well, he travels 10 meters in 20 seconds, and therefore his speed would be 10 divided by 20 is 0.5 meters per second. How far is the object from the start after 60 meters? So you can see that on the graph. He's traveled 40 meters. What about his speed during the last 40 seconds? That would be 1 meter per second. So he's traveling 40 meters back to where he started from in 40 seconds. 40 divided by 40 is 1 meter per second. When was the object traveling the fastest? You look for the steepest line. That would be between 40 and 60 seconds. Here's some points to take from that, some notes to make in your book. A horizontal line means zero speed or velocity and the object is stationary. A straight diagonal line means a steady speed. A steeper line means a faster speed or velocity. A gradient of the line gives you the object's speed or velocity, and therefore a line going downwards would be a minus gradient, which would give you a minus velocity. If it was a curved line, and for the higher level, you'd have to work out the acceleration a bit later. We'll do this, and it means it's changing speed or it's accelerating. If it's curving upwards, we're curving downwards, less steep, it's decelerating. You may want to copy these things down. Here's an example, just to see if you get this. What was the velocity in the first 20 seconds? Well, you divide the 30 meters he's gone by 20 seconds, is 1.5 meters per second. What was the velocity during 20 and 30? His change in distance, he's gone from 30 to 40, that's 10 meters in 20 seconds. 10 divided by 20 is 0.5. When was the person traveling the fastest? Well, hopefully you can see the last section is the steepest, so that's the fastest. What was the average speed for the first 40 seconds? So in 40 seconds he's traveled 40 meters, so his average speed would be 1 meter per second. There's some more examples for you. Okay, what happens if you look at a real graph? A real graph, you wouldn't have perfect straight lines. So this could be a person running, starting from rest, they go quite slow, and the speed up, and you know the speed up because it curves upwards, so they're accelerating in this section here. Whereas at the end, towards the end of this race or this little run, the object is slowing down, so it is decelerating. And for the higher level, you need to be able to work out the speed at any point. You need to draw on a tangent to the line. So at that point there, where the arrow is pointing accelerating, you could draw a tangent to the line, and then you could work out the distance, change in distance, the change in time, divide one by the other to work out the speed. So speed for this person at that particular point in time is 16 meters divided by 45 seconds would be 0.36 meters per second. As I say, that's for a higher level. Thanks once again for listening.